Here's your integrated 3 lecture part 1, 11.1.3. This is adding and subtracting rational expressions. So we were talking about, I think, multiplying and dividing last time. So I hope that you know that you need to get a common denominator when you're adding and subtracting fractions. So we'll just go ahead and do some of these. 11-26. So 11-26, it just wants you to go ahead and refresh your memory about fractions. So we know if the denominator is the same, you just add the numerators, so 8 and -3, right? Same denominator. Even though you have x's, it's still the same thing. You add the numerators, and you can write it over a single denominator. This one, if I have 1/3 plus 2/5, I can't add thirds to fifths, so I need to turn them into the same denominator. So if we choose 15, then I multiply the top and the bottom by a giant 1, 5/5. And then this one I multiplied it by 3/3. And I got 5/15 plus 6/15, and that's 11/15. So we've been talking about giant ones, or, well, like they call it a giant 1. Right, because anything over itself equals 1. So 11-27 wants you to add these two fractions, and you'll see that they already have the same thing in the denominator, so my answer is going to have the same denominator, and I just simply add the numerators. Easy peasy. But now this kind of looks like things that we were doing in the last section. You want to simplify this if you can. So I went ahead and factored this one. 2 times -21 makes -42, so I need something that multiplies to make -42 and adds to make the coefficient of x, which is 1. So I know 6 times 7 is 42. If I make the 6 negative and the 7 positive, then they'll add up to 1. And then this is my area model box that I made for this problem. And so I've already talked about how we do this. I hope that you know how to do this. From here, I get the factors 2x plus 7 and x minus 3. So I wrote those. See, I rewrote the denominator. And then I found that I had matching factors. So that's a giant 1. So I canceled it out. And there's my answer. And then when I do letter B, well, letter B has the same denominator, so my answer is going to have the same denominator. And then 15, you add the numerators, or subtract in this case, 5x minus 15. And then I want to see if maybe I can factor and simplify this some more. So I factored a 5 out. And then here I looked for something that multiplied to make -3 and added to make -2. 3 times 1, -3 times 1 worked. So I didn't need to do, well, I did a little area model box for it, but you don't really need to. You can just grab these, the x minus 3 and x plus 1. And these canceled out. Okay, so that's letter B. And then letter C. So again, we have the same denominator, so we can just leave it alone. We have to subtract the numerators. This one's a little tricky because this minus sign, it really needs to distribute across the numerator, so that's why I have minus x minus 4. Be very careful. I mess up on that all the time, so just be very careful. And then I combine like terms. 3x minus x is 2x. 9 minus 4 is 5. I carried it up from here on down to here. And then I just want to check and see if I can simplify it. So I can't factor anything on the top, but on the bottom, these are even numbers, so I can at least factor out a 2. Once I factored out the 2, I saw that this is a perfect square and this is a perfect square, and if you need to Google difference of squares or go back and find some YouTube videos about difference of squares, this is an example of a difference of squares. It's a plus b and a minus b. So a plus b and a minus b. So if you don't know what that means, look up difference of squares, or you can look it up in your book. And then these two canceled out, so I ended up with 1 over 2 times 2x minus 5. And then letter D. Letter D, we had the same denominator, so our answer is going to be written over that denominator. And then the numerator, when I add them, I just noticed that I had an x and a 2x. That gave me 3x, well, 3x squared. And I had a 5x and a negative 3x. There's my 2x. I ended up with something over the exact same something. So that's a giant 1. That's 1. Then 11 to 8, it wants us to add these two fractions up. So I do not have a common denominator. I have a fraction over 3x plus 1, but my other fraction is x minus 5 times 3x plus 1. So my common denominator would be something that they can both go into evenly, if you remember. So I'm going to choose for my common denominator, I want it to be x minus 5, 3x plus 1. And so then I'm going to add the numerators up. So this fraction has to get multiplied on the top and bottom by x minus 5. A giant 1 of x minus 5 over x minus 5. So that's where this part came from. That's the numerator of the first fraction. There's this plus sign. And there's the numerator of the second fraction. And then I can multiply it out like x times x is x squared, and x times negative 5 is negative 5. And there's my 2x squared minus 2. And then it looks like I can combine the x squared and the 2x squared. That's 3x squared minus 5x minus 2. Okay, and then I'm going to go ahead and see if that'll factor nicely. So 3 times negative 2 is negative 6. What multiplies to make negative 6 and adds to make negative 5? Well, 6 times 1 makes negative 6 and adds to make negative 5. So I put it in my area model box, and I got x minus 2 and 3x plus 1. What? Oh, sorry, x minus 2 and 3x plus 1. And then these 3x plus 1's canceled out, and I'm left with this answer. Oh, I think I might be able to make this in one video. The last problem we're going to do is 11-28, letter B. So I didn't do any of the steps of this because I'm going to just walk you through them. The other ones I already had them written down. So this one, I need a common denominator. The common denominator, at least they both have factors of x plus 3. So I want my common denominator to be x plus 3 times x minus 3. And then I'm going to have a numerator, a numerator from this fraction, and a numerator from this fraction. Because remember, once I get the common denominator, like this, all I have to do to get a common denominator is multiply it by x minus 3 over x minus 3. See? Now they have the common denominator, so I just add the numerators. So I'm going to take this numerator and this numerator. That's how I always do it, because I try to skip some steps, or make it so it's not so long. Okay, now I'm going to just rewrite this a little nicer. So I'll keep my same denominator. This will be 9 minus 3x plus 2x squared minus 6x, right? And then clean it up a little bit. This will be 2x squared minus 9x plus 9. Okay, and then I'm going to try and see if there's anything I can do with this factoring. So 2 times 9 is 18, and this is negative 9. And so 6 times 3 makes 18, and if they were both negative, that'll work. So here's my area model. I take the x squared and put it in the top left. That's how I do mine. And I put the two numbers that I found in the diagonals. Doesn't matter which way. I know 2x times x equals 2x squared. I want my 2 over on this side because I have to figure out 2 times something has to equal negative 6. So that'd be, oh, what am I doing? There's an x. So I got an x minus 3, and then x times negative 3. Okay, so that works. So what I ended up with for this numerator, after it's been factored, it turns out to be x minus 3 times 2x minus 3. And then my denominator was x plus 3 times x minus 3. And then these cancel out, and I end up with 2x minus 3 over x plus 3. That's the answer to 1128, letter B.